need to replace the biggest part of our energy mix. We need to replace by renewables. And so some part of that 60% of the fossil fuel will be replaced by electricity, renewable electricity, fine. But there are processes, industrial processes, what we call high heat processes, that cannot be decarbonized using pure electricity, where you actually need hydrogen.
So welcome to Leaders on a Mission, where we speak with pioneers driving the future of sustainable industries. Now, today it's a real pleasure. I'm really excited to have Bart Biebuyck, CEO and founder of Green Energy Park, join us. Now, Bart's got a really unique background, spanning renewable energy, policy, technology, and is really leading the charge in global collaboration to accelerate decarbonisation and the green energy transition. So I can't wait to get stuck into discussing his vision, the innovative work at Green Energy Park, and the vital role international partnerships play in reshaping the global energy landscape. So Bart, thanks so much for joining us today. Really looking forward to diving straight in.
Well, thank you, Simon. Thanks for having me. I'm looking forward for this conversation.
Excellent. So tell me, let's think a little bit about your journey, right? I mean, what inspired you to really found Green Energy Park, actually?
Well, I've been already on a long journey with hydrogen. I started my career actually with Toyota, where I was developing the first hydrogen car, the Toyota Mirai. I lived also a couple of years in Japan in order to prepare that. And then also when in Belgium, I built also more than 10 years ago, the first hydrogen refueling station in Belgium. So, and then I moved to the European Commission to be the head of the biggest hydrogen and fuel cell research program in the world. And so for 7 years, I was the head of that. But then, the middle of last year, of course, the term, which was legally defined, finished. And then it was like, okay, what is next? Do you stay commission? Do you go back to the private side? But for me, hydrogen has been my passion always in my life. And it's very important to stay loyal to your passion. And that's why I decided to go back to the private side and really create Green Energy Park, actually a platform where basically we can show that the hydrogen economy is a reality. Because we see too many messages, just it's too early, or there's no offtake, and you hear this mainly from the big oil and gas companies. And I was like, no, the past 7 years when I wanted to commission, I saw really that there are new technologies being developed, there are business opportunities, early business opportunities, and we should go for it. And so my aim now with Green Energy Park is to show that the hydrogen economy is a reality, and we're going to show that we can produce hydrogen at a economical, viable cost. And I can tell you we are very well on track to achieve that.
Amazing. So first of all, having this passion for 20 years with hydrogen, why?
Well, when I was when I was a young guy, I had a terrible accident at that time, and fortunately I survived it. But it was really nobody knew it for a couple of months whether I would make it or not. And I remember when I woke up at some point in time and during my recovery that I got a very big passion for the climate. I remember I saw from the hospital window, I saw suddenly for the first time again after months being in bed and with pipes and whatever and tubes and all these things, I was like, I saw a beautiful tree again. I said, oh my God, nature is really beautiful. And since then I decided that in this second chance of my life, because that's how I see it at least, that I need to do everything to help and to help nature and to address the climate change that we are facing today. So that was really the trigger that basically decided a big part of the pathway in my life.
And tell me, I just did a search before. I was just having a little look on ChatGPT, right? And apparently, I don't know if this is correct, but apparently 12 to 15% of the world's energy is made by from renewable sources currently, right now.
Yeah.
And I think by 2050, we need to get to 85% of it for kind of net zero, right? And tell me a little bit about what impact you think hydrogen can have on achieving that goal.
Yeah, it will be big. I mean, hydrogen, first of all, needs to have renewable energy, because that's the starting point. You need water and you need renewable energy, and that's how you can produce green hydrogen. So we need to increase the renewables very, very fast. I mean, even 85% in 2050, I found not even challenging enough. I think we should aim for 100% and even earlier. But that being said, I mean, hydrogen will play a role in our energy mix, but I always said it will be between 18 to 24% of the energy mix will be hydrogen. Because we should not forget, if we look today on our energy mix, still, I mean, a lot is fossil fuel. 40 to 50, or no, I think even 60% of that is fossil fuel based. Only 40% is pure electricity. And so we need to replace the biggest part of our energy mix. We need to replace by renewables. And so some part of that 60% of the fossil fuel will be replaced by electricity, renewable electricity, fine. But there are processes, industrial processes, what we call high heat processes, that cannot be decarbonized using pure electricity, where you actually need hydrogen. Also, we see in the mobility that some of the applications, I mean, when you really look at heavy duty mobility, truck sector, shipping, aviation, they cannot decarbonize without hydrogen. So when we all take that into account, we believe strongly that between 18 to 24% of our energy mix will exist out of hydrogen for exactly those two big purposes.
Got it. Yeah. What mix at the moment is hydrogen? Does hydrogen play?
Oh, it's very, very low. I mean, maybe 1%, 2%, something like that. So it's extremely. I mean, we just started because I mean there was a lot of work to actually develop the technology. I mean, more than 20 to 30 years were actually already spent in research. I mean, making the electrolysers, making fuel cells. There was a lot of work, and I think now we come to the point that those technologies are mature and ready to be scaled up. So I believe that now very soon we will see the hydrogen percentage in the energy mix going up quick. You needed to wait until the technology was really ready, and governments all over the world have spent billions of euros in advancing those technologies that hopefully now will generate the renewable hydrogen and the jobs and the that we all envisioned.
So really, we're just at that point of technology readiness.
Absolutely.
Yeah.
Stay tuned, because it's gonna happen.
God, amazing. Because I'm right in thinking, I'll read about this. Hydrogen is it the most naturally abundant kind of chemical in the atmosphere, or
absolutely
one of them?
Everything, almost everything on this globe has a hydrogen molecule somewhere in its formula. Hydrogen is extremely important for us, and I mean, let's not forget the stars are born from hydrogen. Without hydrogen, there would be no stars, would be no planets. So that's very fundamental element in our lives. Even our body exists big parts of hydrogen. So we need hydrogen. No, it's the most abundant element for sure on Earth. But at the same time, it's also not an element that is very easy to handle. It is very light. It is 14 times lighter than air. So if you release the molecule, it's like a rocket. It goes up very, very quick because air is heavier. So that means they use it very much also hydrogen today in the space industry. So for the rockets, because it's so light, that's a very interesting, let's say, property of hydrogen. On the same time, it's also very easy to, when you connect it with oxygen, it is very easy to ignite as well. So you need to be a bit careful. I mean, and it's also the smallest molecule. So it really goes through all the small, tiny holes it can escape. So not an easy one to handle, that's clear, but a beautiful molecule, and a molecule that basically does not harm the climate.
Yeah, amazing. And so tell us a little bit about, you mentioned with green energy park is like a platform company. So just outline the kind of role that, and how you're going to go around kind of, I suppose, driving this transition.
So, for me, the point was with the Green Energy Park, as I said, our mission is to deliver the cheapest hydrogen in the world, and make it affordable for everybody and bring it to every place in the world so that people have cheap energy. Because I think this is a very important mission. It's also, by the way, one of the SDGs of the United Nations is basically renewable energy for everybody, to make it for everybody available. So that's our vision, our mission that we have with Green Energy Park. But then it's like, okay, how do you start with that? How do you get that? And for me, it was about finding the right location, because as I said, you have two ingredients, water and renewable electricity. And so if you want to produce cheap hydrogen, you need cheap water and you need cheap electricity, obviously. And so that's where I was basically looking in the world where I can find that combination. And actually, I traveled quite a lot in the world. I went to Canada, I went to US, went to Middle East, to India, and talked with a lot of African countries as well, in order to see where are the opportunities, where is basically those two elements available at a very low cost. And at the end, I ended up in Brazil, as I found it was one of the only places, in my view, that delivered those ingredients at an affordable price, and is also abundantly available, because it's not. You might find some places that it's available, but still it's very limited. So within Brazil, there is a massive amount of renewables. So they have actually already a green grid. Very few people know that.
Really? I had no idea. Tell me more about this.
Yeah, so basically their electricity grid is already green, especially in the north area of Brazil. It's 98.8% green. That means that they are actually, they are quite far compared to many other countries in the world. Especially to Europe, where it's very, very low still. So they made actually very wise decisions in the past to invest in renewables and green their grid, which from now they benefit. Actually, the area where I'm going to build, there is more than 200, 300 gigawatt of renewables waiting to be built. That's gigantic. This is a massive amount. So they have a lot of space, and so they can build big solar plants. There is also wind there available. The north area, if you talk to kite surfers, they know that area. They love it because there's a lot of wind there. But of course, you can also then generate electricity a lot. So there's a lot of potential over there. They have the green grid. And so I said, okay. They also have hydropower as well. So I said, okay, this is the place where I need to be, because they have an abundant amount of low-cost renewables. And at the same time, they have also big rivers, as we all know. So that was a combination that I found like, okay, that's very good. And then, of course, you look further. You look if there is a space to do it. Is there enough workforce to do it? Of course, I have a whole list developed of checking points in order to meet the criteria where I believe we could go for producing the cheapest hydrogen in the world, and also contributing to the local industrialization and also to create a better life for the people in those regions. And this is exactly what we're going to do as well there in Brazil, in the Northeast. It's in the Northeast, it's not so much industrialized like in the south of Brazil. And so it's for them a unique opportunity to create really better jobs, engineering jobs, high-skilled technician jobs, which are then better paid than what they have today. So basically, it will help to develop also that area. So there is, in my view, only a win-win for everybody here. I always said that for me, the northeast area of Brazil could actually be the powerhouse of the world.
Tell me though, with something like that, do you then, like when you're creating that, do you then have to build your own electrolysers? What's the process from that point onwards in terms of making this a a reality?
Yeah, I mean, after that, of course, you found the best location. Then you need to start looking what is the technology that you're going to use, because there's many technologies. Of course, I was a bit fortunate that I saw a lot of companies developing technology, because when I was at the Commission, we financed quite a lot of companies. I think more than 1,000 companies I financed at that time.
Really? Okay. All dealing with the electrolyzer and the technology and
No, not
development.
only with electrolyzers, generally with all kind of technologies related to hydrogen.
Yeah.
And
Okay.
so that gave me a very good understanding and view where many of those technologies are. And so we're going to select a new technology that is much more efficient, so that that basically with the same type of electricity, we can use, let's say, that electricity much more efficient than what the current common technology is using. So, so that's where we are now. So we are now talking with various electrolyzer companies to provide us. I mean, we will also ask them to join us in Brazil. I think it's very important. And because then they are close to you, and it makes things much easier to build and construct. And so, yeah, now we are on our way with the basic engineering, and then we hope to reach FID very soon, by the end of next year. That at least is our aim, so that then basically we can start building in 26 and be operational in 28, early 28, and that's the timeline. So it's very challenging. But I have to say that all the people are super motivated. They're really, there's a lot of passion and fire in making it happen, because we have a goal in life here, is actually to change and to have an impact in the world. This is what we all want to have.
Yeah, no, amazing. Tell me a little bit about, I read or I hear about, in hydrogen, there are so many projects and programs over the last years that never make it to FID. And I always hear about kind of cost being the biggest challenge, I think, and then it doesn't transport very well, and it's flammable, and tell me a little bit about like what's different here, and when you get to FID, what kind of impact this will have.
Yeah, I mean, the first point, what is always very important to remember is that when you have a molecule of hydrogen, that 65% of the cost of the hydrogen is electricity. And then you have a bit of your capex costs from your investment, can be 15-20%. Then you have some your financing cost, another maybe 5%, some maintenance cost, and so on. But the key point is your electricity. So if your electricity price is very high, basically there's no chance to make it. Because then you always need to go to governments asking for subsidies and so on. And it's basically not a solid business case. That's why, again, coming back what I said earlier, we really needed to find places where you can have access, a lot of access to renewable energy at a very low price. And that was the location that I found, because again, 65% of a molecule of hydrogen cost is electricity. So this was that's the main point that you need to watch out for. And so for us, this low cost actually help us to make that business case, and to be able then combining, of course, with the technology that we're gonna use, that makes sure that we're gonna get cheap hydrogen.
Fantastic. And so where will that hydrogen go? I mean, when you achieve and you come online in 2028, how much will you be able to kind of produce? And where will the application be? What industries will it go into?
Yeah, so I mean, our hydrogen is, of course, our hydrogen production will be a phased hydrogen production. So we start with 1.8 gigawatt, then we will add 1.8, another 1.8, and finally 5.4 gigawatt. But the first 1.8 gigawatt, we're gonna produce it through with ammonia. So we will use ammonia as a hydrogen carrier, because as I mentioned earlier, hydrogen is a very very difficult molecule to handle. So the best way is to transform it in something else. And so in our case, we're gonna glue a nitrogen molecule with it, and then we can basically make ammonia. And then ammonia is basically fluid at minus 30 degrees, or if you put a bit of pressure on it. And that makes it much easier to transport by ship.
Ah,
And so,
right. Okay.
yes,
Okay.
and then
Yeah.
we ship it to Europe. I mean, we ship also to Asia. I mean, everywhere where there are now markets where they need this ammonia or this hydrogen. And then when you arrive back in in the locations where you want to deliver, then you crack it back. Then you basically take off this nitrogen molecule again, and then you stay again with hydrogen, and then the people have this basically this green hydrogen.
Got it. Okay. So a couple of questions. I'm no expert around this. I'd love to know. Is it a complex process to add nitrogen and then take the nitrogen off?
I mean, to make ammonia is a process that is actually very well known in the world. I mean,
Haber-Bosch process,
that
right?
Haber-Bosch project. And by the way, do you know that Haber-Bosch was the first engineer who got, and I think it's still the only engineer who got actually the Nobel Prize, by the way.
Okay.
So I found that quite interesting. And so, but anyway, so it's a Haber-Bosch. It's very well known for the fertilizer industry. I mean, if you go to all the fertilizer companies, they all have these installations being built. But then, of course, the cracking again on the other side when you arrive in the destination, yeah, that cracking is still not so common. So this requires new technologies. I mean, there are a couple of companies having these new technologies. We are also investing in that technology because we need to make it more efficient because you lose a bit of efficiency there. So that is still a bit of a challenge there. But yeah, I mean, that's life. I mean, you need to work and you need to also keep the researchers busy, you know?
Absolutely. But the point is, you can transport it. It's not flammable at that point when it's ammonia. Is that correct? Or
no, but it's mainly toxic. I mean, this is the point. So it's toxicity that's the main concern. But the beauty is that today we have actually already 200 million tons of ammonia per year worldwide being produced. Also, a big part of that is being shipped around the world for fertilizer industry, and so people know, we as a society and people who are working with ammonia, they know how to handle. I mean, as I said, it exists already since decades. So we have developed the standards, we have regulations around that. So it's something that humans know how to handle, and that makes things easier. And that's also very different, for example, with hydrogen. Hydrogen is new, so still the standards are not yet completely finished. The experience is now just starting. Yes, in space industry they have some experience for sure, but I mean in business to business and so on, it's still a very new molecule and where we will need to gain a lot of knowledge. So that's why by selecting ammonia as the carrier, basically you enter a field where basically there's a massive and a wealth of experience and standards available, which makes it actually much more safer to work like that.
yeah, no, great, thank you. And when you do get it to the other side and you do the cracking, how do you get it onto the grid? As it were, is it maybe I've never thought about that. Like, how does that work?
Yeah, no, I mean in Europe we were gonna build a European hydrogen backbone. So this is a network of pipelines that is gonna connect all the countries and big industrial hubs in those countries. Which you have. I mean, what you have today is this natural gas network. I mean, we know very well. I mean, I think it's what is it, 2.5 million kilometers of gas network we have in Europe. So some of that will be repurposed to carry hydrogen. Some of part we will need to be newly rebuilt. But then the idea is, of course, that the cracker is just built next to such a pipeline, and then you can just inject your hydrogen in the pipeline, and it goes to the different industrial sectors. Of course, this will take still a bit of time. That's for sure. I mean, there are some countries that are a bit more advanced. If you look to Belgium, the Netherlands, and so on. They are, I mean, Western Europe is quite advanced in that because it's also a very energy intense region in Europe. It's really, if you look on the energy map of Europe, you will see that Western Europe, Netherlands, Benelux, rural area is really like a hotspot of energy consumption. So that's logical that they start there with building out this European hydrogen backbone. But gradually that backbone will spread all over Europe. But you need such a backbone. Otherwise, these big crackers that you're going to build doesn't make sense, because you need to basically start cracking, and the cracker should not stop. It has to run continuously. That means you need to be able to inject it into the pipeline continuously. But you see these crackers being built all over Europe at the moment. And there are some plants in Hamburg, there are plants in Antwerp, Rotterdam, and so on. And more will come. But this is the way how you will transport the hydrogen, because otherwise, just by truck, imagine you put this hydrogen then in a truck. It's way too expensive to bring it to the industry.
Yeah, understand. And what strikes me about the business and what you're doing is, it's a real global mentality here, right? Global focus. And I'm curious, how, all countries have their own agendas. They all have political agendas. It strikes me that there's a lot of bureaucracy and red tape to kind of overcome with this. Lots of relationships and collaboration partnerships. How do you? What's your experience of this? And how do you find this? And what? Sorry, let's start with that. I was going to ask you about 10 questions. I've got this awful habit of asking 10 questions.
No worries. But of course, there's a lot of different regulations in different countries, and that's, of course, that doesn't make it easy, because you need to follow up all of those regulations and understand. And what we have decided at the moment is to focus first on Brazil, to make it happen, to build it, try to understand also the regulations in Brazil. And then we can expand. I think if you do it too much at once and you try to build everywhere all over the world, you will spend a lot of time on all those regulations. On the other hand, I think there is also a task there for authorities to try to harmonize all those regulations as much as possible. I know they tried. I think this is, of course, obvious. For example, the definition of green hydrogen. This is a beautiful example. Or low carbon hydrogen. So in Europe, in the US, and in Brazil, it's all different. And that's sad in a way. So Europe is the most severe one, or the most, severe one, because they allow the lowest CO2 emissions for still being able to be labeled as green hydrogen. But so that's what we do. We said, okay, let's make sure that we fulfill the most severe one, because then in principle, theoretically, you should be able to deliver everywhere in the world. This is the approach that we took. But yeah, harmonization around the world, that would be lovely. Right? I think they should work on that. But okay, as you know, there's geopolitical reasons, there is an internal market reasons. We all understand that. But of course, for investors and for developers, that doesn't help.
Absolutely. But tell me though, as a leader in the green energy hydrogen space, what have you found most challenging on your journey?
I think the most challenging on the journey is basically still a lot of people do not know about hydrogen. So even though now it gained more and more traction and it's more and more on the agendas of the ministers, still you see that in many places the knowledge is very low, and you still need to spend a lot of time to educate people. Right? And also the technology, on the other hand, technology is moving fast. So many times people who do know then something about hydrogen, they still are not yet up to date with the latest technology. So you still need to also educate them and convince them that that technology has moved forward. So that is a big challenge. The second big challenge is, of course, still the investors. The financials. you still see that a lot of investors are still watching out to invest in hydrogen projects worldwide. Doesn't matter which project in general, because it's still new. On the other hand, it offers opportunity if you invest, of course, in the right project. But if you look, for example, towards solar or wind, those business models are known. I mean, I think they probably have a handbook next to them. They can just look into it. They have all the numbers. They know what are the costs. They know what it generates. They know exactly if you build it there, how much megawatt you will get per year and whatever. So they all this information is available. So it is actually a business model that a lot of investors know. With hydrogen, a lot of investors, first of all, don't know yet the technology. They heard about it, so you need to educate them, as I explained. But also, the business model for hydrogen is not yet standardized. They don't know, like it is with solar or wind energy. They know if you build a windmill, okay, they know exactly what it will generate. They know exactly what it costs. They know exactly what are the returns and so on. With hydrogen, we still need to develop and show that. And that's where you see that the investors' world are still hesitating to massively go for that. But it needs time. I mean, it was the same as with the, I would say, the renewable energy sector in the very, very beginning. If we talked 20 years ago, probably they were in the same situation. The only difference here is that there is a time pressure, there's a time pressure from regulatory framework. I mean, for example, like in Europe, 2030, there are targets set by the European Union. Companies need to decarbonize, so they need to have access to that green molecule. That's a big difference, because that's where on the one hand you said, okay, investors know that from a regulatory framework it needs to happen, so they should invest, but they are still new into this sector, and you really see that this is a challenge, the second challenge. Another challenge is, of course, also the scaling up of this technology. So still, the capacity of the production capacity is still low. I mean, yes, there are some electrolyzer manufacturers that are investing quite well in that. But you see, generally still, I mean, there's not only electrolyzers, all these components and whatever. There's still, I think we need to invest also in the manufacturing of all those equipment still. I mean, it's a market that needs to come. People need to gain experience in the business model and also in the productions, in the usage. Market feedback needs to come. But we need to accelerate, because the big difference is that there's time constraints.
No, got it. No, really interesting. And tell me, how have you found, you had such an interesting career, but being a founder, CEO of a startup, as it were, completely different. I suppose, how have you adapted? What have you found kind of, I suppose, most rewarding and challenging around that journey for you as a CEO founder?
I mean, of course, in my career, I had I always say 3 chapters, My first chapter was with Toyota, where I was the researcher and really working on the technology. And then, you're very deep in the understanding of all the reactions that happen and how you can improve technology. And then I was more like a policy maker, I would say, when I was at the European Commission. So basically, you set out the directions where you need to go. You set out also where investments need to go with public money. And now, finally, in a way, I go back to the private sector, but as you said correctly, in a different role. Now you're a CEO. You need to make it happen. And I think is what I feel is the big challenge is is the convincing of people to really go with you, to go. And so you really need to make people passionate about the project. You need to take them on board, and that's the fun part for sure. I love to do that, but also it comes with responsibilities as well, because if you inspire people, they come along on the journey. Of course, you also need to make sure that you can deliver, and that's very important, so that you don't break the trust with people. But you need to form really a team, that believes in the goal. And for me, that's the most important. You have the goal. Let's work. Let's do that. Let's make it happen. Let's show the world that we can do it, and then you get that passion from people, because alone you cannot do it. That's not possible. So you need to build your team. You need to convince people, many people, authorities, investors. I mean, all type of different people. And what I like very much is you really need to adapt your story, or your, let's say, the way you approach things, depending on the audience you talk to. I mean, if you talk to investors, it's very different than when you talk to engineers or researchers, and then very different than when you talk to authorities. So that's very interesting in my current job. So you really need to think, okay, with whom do I talk today? Okay, and then how shall I address them? So you really need to prepare your talk and your speech carefully.
Yeah, no, I love that. Tell me, just on the financing side, right? If you look at access to capital, or who's going to help build this, and you talk about investors, yeah, well, what are the main pools of finance for this industry, do you think? Is it governments? Is it infrastructure funds?
I mean, for me, it's clear that since this is a very let's say young technology, if the market there's existing a market, but the market is a very low cost market at the moment. I mean, if you talk with fossil fuels, so the market is not yet so super big today. Of course, the market potential is huge. So the authorities should really be the first ones to support. They will not be, I would say, the biggest, let's say, contributors in terms of financing, but having the authorities there is super important for the confidence, and for then the investors that coming afterwards. I mean, this is crucial. So I always say that without having the government with you in your project or next to your project, it is very hard to make your project successful. So they play a super important role, but it's not only being there as just a nice supporter, with a flag or whatever. No, they need to also commit. So they need also to put in some money. As I said, it does need to be the super big tickets, but it needs to be substantial to be credible. But then at the same time, the message is more like, yes, we believe in this project. Yes, we need to go forward. And then you will have, what I always said, a bit more strategic players coming in, like people who, of companies that want to sell their product. Because, like an electrolyzer, for example, I mean, if you would have the electrolyzer company being part of your journey and also being investing in it, it shows also that they believe in their product. Again, that will give confidence to investors. So you have the policy support, you have the technology providers that basically also put skin in the game, to say so, not just sales, but really put skin in the game. That creates confidence then for what I call then, basically the pension funds, big infrastructure funds. They will then come in because they will see, there's a policy support. I mean, authorities are supporting. There is a good support also from the industry who has an interest. So they will feel much more at ease and comfortable also to join in and to put in the money. And those are really the pension funds are really the ones that come in with the big money, but they are never first, I can tell you.
Absolutely. Well, look, I really, we could talk all day about this, Bart, honestly. So thanks a lot for coming on the show today, sharing your insights in de-carbonization and the future of hydrogen. It's been a fabulous conversation, and learned loads about the innovation shaping our future here. So thanks so much for coming on today, and appreciate it.
No, thank you, Simon. Thank you again for having me, and it was a pleasure talking to you, and it was a pleasure to explain a little bit about the project, but in general, where is hydrogen today in the world, where it stands, and what are the opportunities. Thanks a lot.
Awesome. And to our listeners, thanks for tuning in to this week's Leaders on a Mission. Be sure to subscribe for more conversations with industry leaders like Bart.